Hi, in this session we're going to have a look at distributed computing using Quantlab. And we have made an example in which we try to price an Asian option using a Monte Carlo simulation. And then we have a distributed implementation and we have a local implementation so we can compare. So let's jump into this. So what do we have? So we have the code that we want to execute, and here we have made this code into a string so we can pass it to the distributed servers. Usually you would obviously have the function that you want to run on the distributed computers already installed on that computer, but in this case we're actually going to send it before we start calculation, so we need it as a string. Now we're going to look at how the function works. So let's look at our cluster version first, the distributed version, and we take the input parameters from the display, and we create a cluster, a vector of units, and we loop over these units as many as we wish, how many threads we want, and we create a remote cluster of this using the vector of servers that we want to invoke. And as you can see, we have two servers that we want to use there. One called derived and one called Snowden. So this actually calls different physical machines. And we also pass the string, our Qlang string, with the Asian option code that we want to evaluate. So we pass that along with initialization of the cluster. And then we just start this evaluation of this function, and we need to pass the variables to the Asian option using variance as this goes through socket communication to another server. We need to pass them as variance, and then we wait until the evaluation is ready, and we then average out the results, and then we're done. And we have the same implementation that we have on the local computer, the local option pair. So it has the exact same function, and it just has the same call to the local function to get the payoffs. So we have something to compare with. Okay, so let's start out by trying some different settings. And we can see here that we have 100 steps, and we do 10,000 simulations. And we ask for one thread per machine. And then we can see that we get two threads since we had two machines, one thread each. And the timing of this, we can see that we're actually getting worse performance of the two distributed machines than we're getting on the local machine, with some variation. But this is natural as we have such a small problem. The overhead of sending the problem to the other machines eats up our gains. So let's see if we enlarge the problem a little bit. So we take 100,000 simulations using 100 steps each for the averaging, and then we can see that we're still not gaining over the local implementation. So let's see if we can better this by adding some computing power. So let's take 8 threads. So we get 16 threads, and now for the first time we're beating the local machine, single threaded, and we can then take it even more. We take 1,000 steps and 100,000, and then as the problem becomes bigger, each thread on the remote machines gets a heavy load. So we're going to win over that machine. So now we have a ratio of 1 to 5 using 16 threads, 8 on each server. So now we can actually have a little look at what happens on the second. Let's have 24 threads. I'm going to now reduce the number of machines to one machine so we can see it more clearly. And let's do a rerun of these 24, and then we can see that all of them are working. and now we have to wait for a couple of seconds to get our local server, the one single-threaded version, to do the calculation. And we can now see that we're getting a ratio of, well, better than 10 to 1. And as we increase the size of this problem, we're going to end up with having a linear scale in the number of processes as long as the overhead is becoming smaller and smaller. And this was a very simple example. And as you can see in the function browser, you have a complete set of functions to create your own distributed computing, either locally or externally, by using the function library for distributed computing, where you can have more control and communicate between cluster nodes and things like that if you want to have complete control. And that's what I wanted to show you in this session. Thank you very much.